All right. I thank everybody for coming here today, and I thank everybody's interest. So I guess we'll just get started because there's a lot to cover today. This is NOAA Central Libraries Getting Started with Python webinar. It's a 2-day session, 4 hours in total, a crash course. This was originally started as a result of two previous sessions that took place out in College Park, out at NCEP. I have some names to give credit to. Sorry if I butcher them. Rebecca Esamali and Dr. Creedy. I'm not going to bother butchering these names. You could read them. And then another librarian out there who was instrumental in organizing them. He did a lot of logistics, also setting up in-room, providing facilities for people to come in, NWS employees, staff, which was really helpful. So that's where the credit is due to those individuals. And so just to get into it, this course is broken up into 4 main sessions over 2 days. The first two aspects over today involve getting up your development environments and basics of Python. And then the second portion for today will be visualizations and also covering Numpy and pandas. So if you're looking into data analysis and have a background in statistics, those visualization aspects and data analysis for Python may be of interest to you. And then on Friday, we'll be going into visualizing data with CartoPy, and then we'll also be covering NetCDF files with Python. And so these are some of the packages that we'll be going over. I'm not going to go over them now because we're really just going to go into them detail as we go through each notebook. So I already provided installation instructions, and there's the links to them. If you're not able to install Anaconda on your computer, work computer, or personal computer, that information is there. And resources for all resources. Each notebook will have resources at the end. And then also, before doing this, I created a LibGuide on the library's LibGuide site for additional resources. And so finally, I will ask that everybody at the end of these 2 sessions, whether you go to both or not, I'm going to send out the email regardless, that you take a brief, maybe 2 or 3 question survey. So if I were to do another webinar in the future, you would sign up, or I could use this information to improve any future webinars. All right, so we will kind of get into the meat of this right now. So to just kind of get going, what is Python? It's a general purpose cross-platform programming language. It's used for a lot of different things. It's been around, I don't know, maybe it's been around quite a while. You can look that up. And maybe most importantly, what I find interesting about it, it's free and it's open source. You don't need some enterprise license for it. And then it's also very important for anybody that's new to programming or new to Python. It's reasonably easy to learn. Why is it reasonably easy to learn? It's expressive, it's very succinct, and unlike other languages like JavaScript, white spaces do matter in Python. It's an interpretive language and it's dynamically typed. And also for a lot of people maybe at NOAA, it has a large ecosystem of scientific libraries, which we'll be covering on day 2. And there's a large community of scientific users, and there's a large code base. And furthermore, there's some more details about investment into the earth science Python community and specific agencies that have spent money and resources into scientific Python. And there's a link for Pangeo, and that goes into detail. And maybe for some of the individuals interested in HDF files, netcdf files, and grib files, there are packages that allow you to interact with those files. And that's what we'll be covering on day 2. And so the cons, it's not the fastest language, it's an interpretive language. And then also, multi-threading is limited. If you know what that is, there's also a specific link to what Python calls the GIL. I'm not going to mangle that. So let's just go into setting up your environment. I have this big red prompt for Python 2. You shouldn't be using that, not only because it's a security issue, and NOAA IT does not like that. We want to be friends with NOAA IT. And also, more importantly, or maybe not more importantly, but developers are starting to drop support for Python 2. So if you're already programming it, or you will be programming it, programming in Python, that's going to be going away. So libraries will be just removing support for it. So Anaconda, some people may have had trouble with installing Anaconda right off the bat. I know NOS for sure. I got an email today. But what is Anaconda? It's just a streamlined package management Python distribution for scientific libraries. It comes bundled with, like I said, scientific libraries. And it also, I think a lot of other people will notice with the installation instructions I sent out, it has Spider. It also has the Anaconda Navigator. It's kind of a one-size-fits-all. It may not be useful for everybody, as I'd say Python itself just may be sufficient. You could just go download Python, and especially if you're considering just getting involved with scripting, and not necessarily scientific programming itself. One of the things that is an issue possibly if you just have Python on its own is that you have to do additional installs of additional packages. So that could be tricky, especially if you need to manage different environments within Python. And that may be an issue for admin rights here at NOAA. And so we're going to kind of talk about, so I've been talking about environments, and that word might get conflated a bit because you have your Python environments, but you also have your development environments, how you want to program day to day, and feel free to add comments if you get confused. I get confused myself, but so there's Spider, which I provided in the instructions just to kind of test around, mess around with. There's also Jupyter Notebooks, which we are actually using today. We're using Jupyter Lab, which is the newer version of Jupyter Notebook. And then there's your maybe what you call your more traditional text editor. There's Vim, there's Atom, and then there's Microsoft's Visual Studio Code or VS Code. And those text editors are run in addition with, a command line tool. And that's what I traditionally use with, as I primarily do a lot of scripting in the library. And then, so Jupyter Lab and Jupyter Notebook, they are like a web app tool for which they're especially helpful for not only kind of working through code if you're doing a lot of data analysis. It's very big in the data analysis community. But one of the other main benefits is that not only can you share your code, but if you package it within a specific like environment, you could share the same environment you were programming in. Like when I say environment, the same Python packages that you're using, and then you could kind of reproduce the same environment and share that with the same notebooks. And so you don't have to set up your environment and then run in order to run those same notebooks. So like I said before, Jupyter Lab is kind of the next generation of Jupyter Notebook. So and it has improved user interface. And I would say, just to show a quick example, one of the biggest improvements is that you could show multiple tabs in one window. So this was not possible with Jupyter Notebook in the past. And so you could essentially also, I'm not going to do it for the sake of not confusing myself, but you could copy and paste code from different notebooks while having both tabs open. And that was one of the big demands when upgrading Jupyter Notebook. So I also wanted to mention Jupyter Hub because I believe somebody asked about possibly using Jupyter as a collaborative tool with all their staff. And so what Jupyter Hub essentially is that you run Jupyter in like on a server, and you're allowed, everybody's able to collaborate. That may not be the most descriptive, but I did put a link there, so you could look into that. That way, also, you may not run into IT issues where you're setting up Anaconda and they say, oh, you can't run Anaconda because there's some admin rights there. So that may be something worth looking into. So I already have Jupyter running on my machine. I don't know if anybody doesn't, but I have some directions here for running Jupyter. And the directions say cd into the directory. If you don't know what that is, essentially you want to get into the directory where the notebooks are for this demo, and so, or this webinar. So what I could do is just quickly show everybody. I'm on a Mac. If you're on a Windows, it may be slightly different, but the key point is that you want to go to the directory where the folders are in your terminal and launch Jupyter from there. So I could go into my Mac and do that just for everybody's sake. And this will launch in my in Chrome for me. And so it looks like that. And you will see all the files and any related directories to the left. And so that's just a little basic demo of how to properly launch it to follow along. So I'm going to take a sip of water for a second. If anybody has any questions, please feel free to ask. But I think I will just go ahead straight into actually what Python is. So basically, start with the basic data types of Python. I think if anybody has any background in programming, they're probably pretty familiar with this. I want to presume everybody is familiar with programming. That's not bad. It's not a good thing in a webinar for introducing programming. So Python has strings, integers, floating points, and none type, unlike other programming languages where it may be null. And each type has its own set of methods. And so before I get any further, I should say Python, and in Python, every everything is an object, and so objects have methods and attributes. So if you're familiar with object-oriented programming, that makes sense. If you're not, I hope to kind of further clarify that as we go on. So everybody, all the notebooks have a lot of print statements. Everything's kind of already run, but I will show a little more. So as you can see with strings, you will get hello world just immediately after, once you run it. But this is what a method is. You know, essentially it's a function that's run on. I need to take a little second. But yeah, it's a function that's associated with an object. I believe so. But yes, so, and what, as you see split, that will actually split a string into a list. And so we could actually, if we want to split not on, if we want, we want to stay on this page. Cancel. If we want to split on A, we can, and that will not do anything because there's no A's in hello world. So basically splits the string based on whatever string you put in there, and it creates a list object as a result. And so Python also has integers. That's pretty basic. You could run an operation on and you could add them together. You could run basic operations that many other programming languages have. Python also has floating point numbers. I believe it is double, it's double precision. I should have thought of that before this webinar. Booleans, unlike say JavaScript, they are in they are capitalized, and it's pretty basic. Again, if you have any questions, please ask me. And then none, it's basically, it's not an empty value. Essentially it denotes a lack of value. And I would say one of the good things, or one of the most used, or one of the, it's often used in conditionals. So and we're going to get to conditionals in a second, but I want to give you a little demo for a second. So if, as we know, A already equals a integer or a value, we could say if A is not none, we will return a value. But we already know that I don't know why that is happening. Oh, if A is not none, it's a double negative. It will not return anything, but if we say if A is not none, we will return a value. So that is one of the that's one of the many times you'll want to use none. And then, so to show one of the unique values of using Jupyter is that you could run what they're called magic commands, and in this case, whos will show all the variables that are run at the time, that are currently in play, or that are currently in the namespace at the moment. So as you can see, these are all the variables that I've run so far. And so as you can see, A is a string, B is an integer, E is a none type, and then I was running this earlier, so you're going to see a function. So yes, this may be useful, but more importantly, what I wanted to show is that Jupyter has magic commands, and so you're able to kind of do some meta programming within Jupyter. And so next we're going to get to the basic data structures of Python. And in Python there are lists, tuples, dictionaries. Other programming languages will usually say associative arrays, and then there are sets. So if you're familiar with set theory, you should be able to grasp that fairly quickly. And again, like the data type, basic data types, each data structure contains its own set of methods. And so I'm going to, maybe this may be easier for both everybody watching and myself if we do this. I need to run everything. Is that a list, and maybe it's a bad thing that I'm making comparisons to other programming languages, but a list, say in JavaScript, is often referred to as an array, but an array or a list in Python is indexed and mutable, and so this is, you create a list with brackets, and then it doesn't have to be just basic strings. You could do integers, but you could also mix it in with strings. So you could have heterogeneous values in there, and then but we will remove that. Oh, and I did actually put that in there right below my varied list. And then as lists are mutable, you could append new items. And then one of the more important things to remember about lists is Python's ability to what's known as indexing or slicing, which is very powerful. And its lists for Python are zero-based index. So not only can you select the first item, but you could also get the last item. And then you could reverse list. And so this is not only, it's used quite commonly, but I think for the second portion of today, it's especially powerful for Numpy, because Numpy gets into multi-dimensional arrays. And so tuples, they're also, unlike lists, they're immutable. So you could build up, your tuple, you create your tuple through the satellites variable, but I intentionally tried to append a new value to this tuple, and I get this error, and it will say that you can't add to a tuple because it is immutable. And so that's one of the differences between tuples and lists. And so with dictionaries, these are key valued pairs, container types. And so some of the major methods to be used with keys are with dictionaries is that they have the keys methods and the values method, and that allows you to select, in this case, the fish names, and then also the values of the fishes. And so I'm going to show you another important method when I cover the loops, or different aspects of flow control below. But if anybody has any questions, no questions? I'm sorry. I'm totally sorry. Someone who is actually with me mentioned that all questions need to go in the question panel because I have everybody muted. I'm extremely sorry about that. All right, so we're going to go over flow control. And so basically, one of the maybe central aspects to remember about flow control is that as our loops, for loops in particular, so iterating over items. Again, unlike Python is a very simple, not I shouldn't say simple, but relatively easy language to grasp. And one reason I would say, maybe not one reason, but anyways, for loops, unlike other languages, don't use the C style loop where you need to kind of build up an index. It's similar to a for each loop. You simply iterate over a sequence, and it's relatively basic. And so you iterate over a sequence, and it will print out that sequence. So if we remember that list of hurricanes, we just iterate over that, and then we get those list of hurricane names. So for name and hurricanes, print name. And so furthermore, Python also has this helpful range function. It's a built-in range function. And so we just put in the values of for it could be item. That's just kind of a placeholder term. And we get 1 through 4. And so for range, as by default, starts at 0. But we could change that to get to start at 1. And so in addition, one of the other nice features that if we do want to show an index, we could use Python's built-in enumerate function. So like before where we iterated over hurricanes, we could add an index with Python's enumerate function where we just wrap enumerate around the hurricanes list. And so when we do so, we get this index in parallel. And like other programming languages, there is the while loop, where we have a count. We start a count at 0, and then we get the length of the satellite. And this is I did not go over this function, but essentially it counts the length of the list. And then we want to use a little print statement to the length of the satellite list, and then we run the while statement or the while loop. And so I've been going over the basics of looping and conditionals, but to just combine them to show, we have we're going to go over this fishes dictionary. And so like I showed before with fishes where we had keys and values, we could iterate over both items. And let me actually just illustrate this for everybody. This will iterate over both. And by doing this, we could build in a conditional where we just want to get we want to select the values of salmon if they are present, and also the values of tuna if they are present. And what I did here is also show, let me get the time, show different ways of printing out in Python with interpolation for the first one, which is Python's newest way of interpolating values into print statements. And this f-string style is the newest way. And then also the format method is slightly older, but it's more preferable than previous methods. But I would say going forward, f-string style is definitely more preferable. And then what is another important aspect of looping I would like to really mention is that list comprehensions. This is something that's really unique to Python. in that you basically could do a one-liner with a loop. You don't need to rely on for loops all the time. Essentially, you just package a loop within brackets. So to kind of give it in plain language, you're saying for item in list, and then let me do something else. Item in list within brackets, and that will return your looped value as these ones show. And then furthermore, in addition to doing this, you could also build in conditionals. And so you get this, if I want to select only hurricanes that have E in their name, you get this filtered list. All right, so if we have any questions, oh, we do. That is actually a good question because I don't regularly use tuples. I believe one of the major, so one of the questions that I got was, what is the use case of tuple over list? This is actually a good question, and maybe some other people that have programming experience. I know this, from my understanding, I don't regularly use tuples, but I believe they're more memory efficient, and I've seen that they're used in a lot of database workflows. But I wish I had a better answer. I don't regularly use them. I use lists a lot because it allows me to parse things easily. But more importantly, I should just say that it allows me to add values. Honestly, I wish I had a better answer. I know I'm supposed to be the presenter on Python today, but I have seen, I know in SQL, like SQLite databases, the tuples are used more often because you don't need to kind of update the values. You want to keep them, you don't want to mess with the data. Let's see. I know everybody can see my screen. So all installation, that unfortunately is not going to be covered. Someone asked about installing. That's not going to be covered at this part of the webinar. This will be recorded. If you could email me after the webinar, and I could try to help you out. But I would say just kind of sit back and relax. Are there definitions? Is there a definition list for each item that I've demonstrated? I plan on at the end of both sessions providing more documentation for everything, and I would say that with the post-webinar session, to please contact or please fill it out, and if you have any suggestions, I was going to kind of send it out to everybody. Oh, someone actually provided a good follow-up for tuples. Besides memory, which may be a rare case for most common cases, there's a safety case for tuples when you want to ensure the list won't be modified. And I think that's kind of what I followed up. I kind of brought up is about the safety case. You don't want to modify the data. Yeah, so this will be recorded. It's going to be posted on the library's YouTube at a later date. All right, so we're going to go into functions. So functions, they're, like most programming languages, and even in your Excel, other spreadsheets, they're an efficient way to reuse code. You divide code into blocks. It's like a little black box. Just reuse it over and over. They could be called repeatedly. You could, importantly, you could import functions into separate modules. We haven't covered modules, but I can mention something about that. Functions can contain parameters, of which you pass arguments into. That's a little abstract, but I'll show you in a second. And also you could pass functions into arguments, which I will show you down the road. So some nice basic functions: add, subtract, and subtract. I thought I had another one. So we run those. So basically, a function definition Python is DEF, and then what you want to name your function, and the return statement. That's an important thing to have. And that basically is your function. You can also do no return statement. But one of the other important syntax, or a couple important syntax features about functions in Python is that you don't have to have brackets within Python, unlike other languages, and you need to have a colon at the end of your function definition statement. So yes, you don't always have to have a return statement, but if you want to kind of later use your function and another later on in your workflow or within your code, it's important to have that. But this is kind of a useless function. So I need to call it. So when you run a function, you call it. So that's a term you will hear a lot. Oh, I need to. So the useless function has run. All right, so take a sip of water. All right, so I'm going to go into more details with how to use functions in a hypothetical situation like this one. For it, I used some of National Weather Service's storm report data. And what I did, instead of using the daily reports, I just aggregated all of it into a single month. And so before we do that, because it's on a different it's in a different directory, I need to import it. I need to get it. So one thing I did, and we're also going to be, it's a CSV file, so we're going to have to parse it. So what I did is I imported it using, I imported 2 Python modules, in which those Python modules, to import them, you use Python's import statement. And so those are the CSV module and the OS module. And important to cover is that Python has an import statement, and basically to import different modules that you'll be using for different situations, you just run import and you'll be able to get new functionalities into your program. And so one of the important ones, especially if you're going to be doing any kind of scripting, is to use OS. OS allows you to do different operating system functions, and specifically in this case, it allows me to go grab files from different directories. And OS path join in particular, say if you're working on something on different operating systems, you're allowed to kind of make I would say, an agnostic program that will run on different operating systems. So you have like the DOS weird file system like situation with the slashes versus a Unix file system. So OS path join will allow you to join paths without any issue. And so essentially we create that, and then now let's actually get into functions. So a Python function, we defined one earlier, and so we have this function, and what it does is we use Python's with statement, and that allows us to either open and read or write CSV files. And in this case, when we open it, we are actually opening it and creating it a dictionary. And when we turn it into a dictionary object, and we're going to loop through that dictionary object. And as you remember, when we loop through, when we have a dictionary object, we could access things by keys and values. And maybe I should actually show you the data, because when we loop through things through keys and values, we could select things like their headers, which are their keys in this situation. I know this is actually confusing me just talking about it. So when we loop, say for instance, with the CSV dictionary reader object, the keys in this case become all the headers, and the values become all the rows below. So what I'm doing is scrolling down, and I'm selecting this state header. And so when I select this state header, I'm appending it because I'm appending it to the empty states list. And so I'm going to return it, but before I return it, I'm going to use Python's set object, our set function. And so I get a list of all the unique states, the unique list of all the states in that file. And while this printout is not the greatest, what I'm going to do is, it's not going to let me do that because I did not run this first. I did not run this first. That is actually, I want to point that out. That is one of the confusing things about Jupyter. You have to always make sure that you run every cell before you run. You have to run every cell in sequence. This does not improve the output, the look. And that was just a duplication. And so we move on to the next before we move on, what I want to show, one thing is I have this long comment, and what this is in Python is a doc string. And one of the great things about Python is that they have a lot of documentation for not only within the code itself, but the Python community. And so you could actually access this whenever you're in within Jupyter, or actually within the command line if you have certain tools within your text editor. I may get this wrong, but if you use you will get the doc string here, and it will give you information about what the function does. So that's why I added that there. And so now that we have all the unique states that we wanted, we have this function that we could utilize that information. And so we have this with statement again. We're gonna reuse that data like before. We're also going to use the dictionary reader, and then we're also going to go through and find what we want to do this time is get the data from that state. But one of the tricky things about it is that we actually need to, because it's only going to get the data from the state, we also need to get the header. So we use this next function. This allows us to just grab the header and add it to that empty list that we created to actually use for later returning all the state data. And so when we loop through it, we get all the state data. I believe I changed this before the webinar. So previously it was in, now it is equals. So I'm sorry about that, but just that was a little more, the previous version was a little more generous, and to be honest, incorrect. And then this may be a little, this exception here, I've added this here to kind of show another feature of Python. Essentially, if the state is not present, it's going to throw an exception. It's going to raise an exception. So if I'm not going to run this function yet, because what I'm going to do, as I mentioned earlier, functions could be passed into functions. So what I want to do is use this function that will return state data, and I want to write it, because one of the fun things about programming is that you could get all the stuff, you could return all the data, but you often, the next challenge is to write it to a file. So what I do for this third function is I actually write the data to a file, and so I use that path join again, and then I create my path and I create my file. This time I use the state which I'm passing in the variable, and then I create a file name with it. And then I use the with statement again. I make the with statement again write this time instead of read. And then I loop through the data, and I use that state function, get state data, and I write it to a file. And so when I run it, this time I'm not going to use Oklahoma because I already did that. I'm going to use California. If we go to state data, we have California, and I want to stay on the page. And so if we try to do a fake state, we will raise that error. And I think I will ask some questions. Yeah, so it looks like we may have some questions. Where is the... Yeah, let me see. Does tab delimiting signify codes of line in a function? Yes, I'm sorry. Yeah, that's, again, one of the things, white space matters in a function. So let me actually, can people see my screen? All right. So yeah, so I'm going to close out of something. Hopefully it doesn't do anything bad. So yeah, I'm going to use IPython. So when you create a when you create a function, you automatically get a code block going on. So return yes. So that's a yes. Oh yeah. So if you want to comment out code during a test, you just want to use a pass. So def not ready I'm sorry for the bad humor. You just want to use a past statement. So the difference between a single equal sign, double equal. Single is, I really should have gone over variable assignment, but essentially single equal is when you want to assign a value to a variable, and double equal is when you want to evaluate whether two values equal the same value. So let's just say a variable var is 1, so 1, and then let's say var equals 1. Var equals 1 is true. It looks like we're good to go. So now I'm going to close this. And I'm going to show, I think, one of the things about Jupyter is that it's good to kind of test code and kind of like basically, troubleshoot what you want to do. But what happens when you want to like kind of put this code into production or move it to the next step? And that is, not only can you export it, one of the things I primarily do is I just take it out of the notebook as a Python file. So you could export as text file, HTML, LaTeX, Markdown, PDF. But what I'm going to do is export as a Python file. And so you get the executable script. We want to keep it. And we will drag it into our text editor. And we will have all this ugly looking stuff, but we will have the code itself. And then from here, we could get some stuff here. And then we could go from the next level of actually creating a script. But I think that kind of covers the first portion of the code, this session. I see that, believe there's another question, but there isn't. I'm going to wrap this part up with some resources for beginning programming. Maybe one of the most popular is Automate the Boring Stuff with Python. That is not only a good source for learning Python in general, but it has really good use cases for everyday stuff within the workplace. There's this guy, Corey Schaefer, on YouTube. He's really helpful. He goes over everything, a lot of different Python aspects of Python. Not too technical. That could be an advantage and a disadvantage. And then I put down PEP 8, which is it's a style guide for Python. If you're learning Python, I would recommend that you check that out, because the more you learn, you don't want to kind of create some eccentric style, because you'll start to look at everybody else's code and then say, this doesn't make sense. So that's helpful. And then I didn't cover modules and packages, but that's especially helpful, especially if you want to build scripts or packages, because the importing of modules and packages could be kind of tricky. And then I also put down PyVideo. That goes into a lot of different stuff. You could search for web frameworks, data analysis presentations, and they go into the more nitty-gritty. And then we have our LibGuide. I would just check that out. And then Commerce Learning Center. I don't know if anybody knows this, but they have a bunch of programming videos. If you're a Fed on there, you could get on there, not just Python. And they're on there. Also, if you're a federal manager and you think people should be learning Python, sign your contractors up. So I believe we have 2 questions. I could send you the I could send you this I thought I sent this out. So basically, Mark, I believe I sent this out, but I can send it out after I'm done today. Um, I will have everything sent out that's a part of this webinar. What is the value in writing code for Jupyter, or writing in JupyterLab versus IDE such as Visual Studio? I would say one of the benefits is that you could share code. It's a good tool for collaboration. Keep in mind you have to have the same environment. If you're going to be sharing code, you could have some issues there. I would say that's one of the main benefits. It's good to have a understanding of Jupyter if you're, say, in the data analysis community, because a lot of people use it. But I would say if you're doing a lot of scripting, maybe it's not the most valuable thing to learn or utilize on a regular basis. So, and I would say those are the two main, the plus and minuses. The next part is going to be kind of more the same, and we are going to be, I will be pulling this up right now. So we are not going to be doing necessarily any working examples. You're more or less, you can feel free to like follow along in your terminal. So yeah, let's just get into that right now. I'm going to take a sip of water. And a sip of coffee. But maybe I don't need that. All right, so the person in the room is laughing. So the second half of today's session, and we are actually on good time, is Numpy. It's kind of the foundation of Python's like scientific computing. It's the foundational scientific computing library of Python. It's like strewn throughout all other packages of Python scientific libraries. If anybody else wants to chime in with anything about that, feel free. Pandas, which is built up on top of Numpy, as not as robust, but it's very helpful, and it's utilized a lot within the data analysis community. And then Matplotlib is a foundational visualization library of Python. So let's just get into Numpy. Numpy provides high-performance, multi-dimensional array objects and tools for working with multi-dimensional arrays. Like I said, it's a foundational package for scientific computing with Python, and comes with Anaconda. You could install it without Anaconda as well if your IT is giving you trouble about that. So again, Python's import statement to get it into your environment, you just import it. But one of the things about Numpy is it's commonly imported with an alias. So Python's import alias, the way to import it with an alias is just to use as, and then with Numpy, it's just NP. And so Numpy, the major aspect of Numpy is Numpy arrays. When you create a Numpy array, it looks similar to a Python list, but there are many differences, and so I will get into those, but let's just show you how to create arrays in various different ways. So the first way is just NP array. This will create, the first 1 through 12, and then I'm going to comment all this out. and run it, but I need to import and run. And so I'm very sorry about this. I should have said when you want to run a cell in Jupyter, I'm really sorry. You hit return or shift and return. If you just hit return, you won't be able to run the cell. You need to hit shift and return. This is kind of what happens when you kind of are a solo programmer. And so Numpy has various different ways to run random, to get random arrays. And I don't know why that is doing that. Oh, I see. So this will, one of the major aspects about using NumPy is you could create multi-dimensional arrays. And so I created two, I believe it's the three-dimensional array. It is a three-dimensional array. And then there are various, these are the various different ways. And then you could, the line space will create, return an evenly spaced numbers over a specified interval. And this is printed out in scientific numeration. And so one of the important aspects, especially if you're working with large set of values, is to kind of just get a snapshot from a distant view, and that is to use the shape method, and that will return the actual shape of the arrays. And specifically, it will show that this is a random array 1 is a three-dimensional array, and then array 3 is one-dimensional, and then you could use ndim, which will return how many dimensions there are, and then another important aspect or another important method is to use a reshape, which will actually take a array that is just one-dimensional, or it will take a array that has 12 values, and you could reshape it as long as it doesn't, as long as the new shape has the same amount of values. And so as you see, there's 12, and now there's one-dimensional, and now there's 4, 3, two-dimensional. And so this NumPy, as someone that doesn't regularly use it, it can be tricky, but again, it's kind of foundational within the scientific community. Other methods allow you to run operations. You could sum everything, the entire array, but you could also sum along the rows, and you could sum along the columns. Like Python list, you could access through index, zero-based index, and then so you could also slice, but unlike Python lists, which are one-dimensional, you could NumPy arrays, which are multi-dimensional in many cases, you could do this on a multi-dimensional. You could slice on a multi-dimensional basis. So this will get the first array in a series of arrays, and I need to run this. And I may have to share this updated version because I did this, so I'm not sure if everybody has this, but you can see that I'm able just to parse out various values in various arrays, and this is especially helpful if you have a data set of just numerical values. And I have more information on resources on carrying out these specific operations. And before we go any further, I will look at questions if we have any. We have a number of questions. Oh, no. Are the NumPy, pandas, and matplotlib lib library strictly quality controlled to ensure. Um, yes, so so those three packages are part of part of Python's like SciPy ecosystem, and so they are widely accepted by the STEM community. I would say so. I did not actually talk about like SciPy in general, but they fall within the SciPy ecosystem. There is a SciPy library, but I did not. We just don't have time to cover that. I would have to look into that about IEEE, but I could get back to you. I could give you resources at least on SciPy, and I like Pangeo definitely. I know UCAR is switching over to Python for a lot of their workflows, and I could give you that information if that is helpful. Oh, let me, we don't need to go into a session about questions. um, there we go. All right, so one of the helpful aspects about using Numpy is that we have, can I just, there we go. Numpy has masked arrays. So you have a large data set of arrays and values, and you have some invalid. So you're allowed to filter out invalid values relatively easy. One of the downsides is that these operations are slower than regular NumPy arrays, and so it's a subclass, and the components are the array itself and then the mask that you apply in the output, and I will show you that as I go on. So again, the import statement, you're actually going to import the masked array module and then alias it. So what I do here with the X is I create just a range just to kind of show. And this is one way to create a masked array. It's a very manual process, but in this case, 0 is a valid value and 1 is the invalid value. And so we get this output with the actual array and then the mask. And so to show, that to show the difference, if we sum it before it's masked, and then we sum it after it's masked, and we can see the difference. And so say you have a large data set and you want to mask all the invalid values, you could do that, and it's relatively easy. And so furthermore, you could use conditions where you filter out, and so certain values. And so you could use greater than, less than. In this case, we use greater than, and we see that we get the data, the array, and then we get the mask below. And this is used, I get into this later on with netcdf files, as netcdf, Python's netcdf libraries go into the use NumPy in the background. And furthermore, this is a little more complex case where we're using a where conditional to kind of find anything that is less than 10. And so we see that we filter out a value, and this is just like a basic demo. And again, I have more resources on masked array. Python, or NumPy's site has a pretty good tutorial on this. So pandas, this is probably one of the most popular for Python's data analysis community. It's built on top of NumPy. It's a library that encapsulates data with labeled access. So I've heard it referred to by some people as like Excel on the command line, but I think that kind of does it a disservice. it's comparable to R's data frames. Some of this stuff I'm not familiar with. Structures in IDL, namespaces in C++ and modern Fortran. The two primary structures in pandas are data frames and series. The one thing to keep in mind about pandas is that it's really great for working with heterogeneous tabular data. You want to remember with Numpy, it's good for working with like homogeneous data and multi-dimensional data. And so the pros is that you could label columns with names. And also it makes grouping operations really easy as a result. The cons is that it's not as fast as Numpy, but I think for the most part, you're going to have different use cases. And so let's just let's get into some use cases. So again, we're going to use the storm reports data. I promise we'll be using different data going forward. So the import statement again, we're going to alias it with PD. Common convention is that's the case where you use PD, and you will often see that. We'll import OS again. This is not normally done in Jupyter Notebooks, but I added this pd.optionsDisplay.maxRows. This is really helpful if you're using pandas in the command line. You don't want to mess up your whole screen with data frames. And so we import, we create a data frame with pandas, a read CSV method. And what that does is we grab the data and we import it, and within that statement, we get a data frame. And so a data frame encapsulates all the data within its data frame. So the easiest way, one of the easiest ways to see that everything is okay is to use the head method, and that will print out the first 5 rows of a data frame. You could also, we also need to run this one, but you could adjust it to whatever you want it to be. You get the first 7 rows as zero-based index again. Like Numpy, you get the shape. This will print out the number of rows and the number of columns. Importantly, before you kind of do any analysis, you want to actually see the nature of like what you're working with. So the columns, what I guess would be the attribute, allows you to see the names of the columns. You could also use Python's built-in list function to see all the column names. And then Pandas has a nice feature for working with numerical values. So if you're interested or your field is statistics, any column that is a numerical, you could run this describe method, and that will print out some basic statistical information, count, mean, and then all these quantiles. But I should mention that, yeah, that's good. And then another method to use to get frequency counts is to just use value counts. So what I should show before we run this is states will print out all states, but that isn't really helpful. If we want to get the frequency count, we do that. And that's much more effective than running a loop and running some additional code. And then Pandas has a nice feature of Boolean masking. This is helpful, but you always have to remember if you just type in this, if you don't wrap it within another data frame, or if you don't wrap it, you will just get the true false values. So you need to do this. And then Pandas has the LOC method, which allows you to select the column names. This is actually a little more advanced, but this allows you to select columns based on values. So let me show you a more simple version. Oh, I am wrong. I may have to get back to you on this one. Yeah, I will have to get back to you on this one because I don't, there's just a lot going on with this webinar. I do feel bad about putting something down and not actually immediately being able to answer your question. But yes, I will explain more about that in an email follow-up. So one of the other nice aspects about Pandas is that it's relatively easy to create new columns. So we know from this previous printout that we have 9 columns, but we want to create a new column based on, we want to create a new column for counts, number of states. And so the way we do that is we simply, I need to take a, so actually, yeah, I need to take a second here to read what I wrote, because I wrote this a little while ago. But essentially, we're going to create a new data frame. And in creating a new data frame, we're going to add a new column. But to do this, yeah, so what we do is basically we create, we're going to create a new column, or we're going to create a new data frame. But before we're going to create a new data frame, and in that new data frame, we're going to create value counts for each state. And so, like before, we created this little frequency count. And so to do this, what this evaluated to is a series. As I mentioned before, Pandas has 2 different main data structures, and that's a series. And so what we need to do to create a new data frame is actually, it's somewhat tricky, is that we have to, in adding a new column, we have to create a data frame. We have to go through these series of steps. It's kind of somewhat, unfortunately, tricky. We go through these series of steps of creating that frequency count, storing it in a variable, and then we reset the index. That returns a data frame, and then we rename these columns, because whenever we return the data frame, it has new column names, and then we get this state frequencies count data frame. And so now we could also, finally, we could add the new column of percentages. And so, sorry for the confusion. I just haven't, I ran through it, but I was adding stuff at the last moment. So now I will take some questions if we have any. Oh, we have no questions. So Matplotlib is one of the foundational libraries for Python visualization, but specifically, it is the module located within Matplotlib PyPlot that enables you to generate plots. And so from now on, I'm going to refer to it kind of as, I'm going to refer to it as PyPlot. And PyPlot is similar to Matplotlib. So if anybody is familiar with MATLAB, they may feel somewhat at home. I'm not a user of MATLAB, but feel free to offer any input. So as Matplotlib PyPlot is a module within Matplotlib, you need to import it with the dot notation and then alias it because it's another library that often uses a alias. And so in the case of Matplotlib within Jupyter Notebooks, you need to use this magic statement, Matplotlib inline, or otherwise you may run into errors. And so in addition, to set the specific figure size and within Jupyter Notebook, you need to use these specific statements to get the figure size, but within Jupyter. But there's other ways to kind of customize your figure size within figure or plot size within Matplotlib outside of Jupyter, and I'll show that. And so we run that, and so there are a lot of different ways to create plots within Matplotlib. One of the easiest ways is to just use the simple plot, plt dot plot, and that'll create a line graph. And so what I did is I created some dummy data with Numpy, and I added a title. So one way to add titles within Matplotlib is dot title and an x-axis label, a y-axis label, and so it's going to get a little, oh, it doesn't get larger. There we go. And so that's like a really simple way to create these plots. However, using that pandas, or the data we've been using for pandas, we could also create another plot. And one of the benefits of, and so we will do that. So we could also create a bar plot in that same simple way. What I'm doing here is I'm using the pandas data, I'm subsetting it, I'm only grabbing the first 10 states, adding a Y and an X-axis label. I'm also creating a variable for hail, the title, because I'm going to reuse this over and over. And I'm going to create a legend, and then I'm going to use show, plot show. So what I need to do is, if you're ever running into issues and something is not working right, a variable or a function is not running right, you could go under kernel and run restart and run all cells, and this will run all cells in your notebook in sequence. It may take a second if you have a lot going on, but it will hopefully resolve any issues. And so that plot is created, and then one of the nice things about pandas is that it also leverages pandas. So you could directly call pandas specifically that data frame, the state frequencies data frame, and I call that, I just get the specific columns, and then I say what kind of plot, and I want to rotate the states on the x-axis, and I want to add some different values. Color, let's say we want this green, and alpha will change essentially the transparency if we want the green to be 100. Gone over label and title. And so now we've been doing basic plots. Let's cover the anatomy of matplotlib figure. So pie plot it gets complicated very quickly, as I'll show you in a second. Figure and axis are the two main components of a plot. Figure is the whole plot, including the white space. Plot essentially is the plot where plot is the axis. Our axis is the plot itself. It gets confusing. I hope I'm not pronouncing axis A-X-E-S wrong. But that's the component of the plot. And then further within that, you get ticks and other aspects of plots. But I'm not going to go into too much detail for anybody's sake who is not familiar with matplotlib. And so we'll get into one of the really important aspects of matplotlib is that you could create subplots, basically multiple plots on one figure. And so we are going to create some more. Oh, actually, we have some questions, so I'm going to take some questions before. So the question, I guess you can see my screen. Can you no, you can't see my. Oh, I'm sorry. Can you demo help for a matplotlib method? For example, if I want to change a color, change a plot color, how do I learn the keys, etc. So one of the advantages of, I hope I know the right command, is within Jupyter Lab. Let me see if, there is, if I'll get back to you, but there is a way to, let me try this. This may not be working because I'm using pandas, but so if you hit Shift and Tab, you can get the documentation directly within methods, the methods that you're on, or the specific. So I go to plot label. I get the parameters. So yes, I hope if that answers your question, let me know. If not, just email me. But yes, because one of the tricky aspects about matplotlib, and I'm going to get into in the subplotting, is that once you start using matplotlib in different ways, it starts to, you need to change, the ways you access different methods, or the methods change the way you actually write them. and it's fairly confusing. It's unlike a lot of built-in Python. So for subplotting, we're going to create some, we're going to further analyze the Python data. We're going to subset it. I previously did that with top 10 states, but I'm going to do that and place that data into variables, and then I'm going to use Panda's group by method. Maybe if I have time, I'll show you that more detail. And I'm also, so essentially we're going to further analyze the data, and so we're going to use Matplotlib's subplotting method. And so when you subplot, you need to specify the number of columns, the number of rows. When you for each plot, you need to say which column, which row, and what plot that is. So if it's plot number 1, you need to say plot 1. So we're going to, in this case, we're going to create 2 plots. I need to make sure I run this. And so we're going to create 2 plots. So I say 2 columns for these plots. It's going to be 1 row. I realize I have a typo there, or wrong information. And then it's going to be the first plot. And so for the second plot, I have column, I have 2 columns, first 1 row, and then the second plot. And so like before, I create my plot. It's going to be a bar plot. I get this state frequency data, and then I create the title, and then I run that. And then difference from before is that I add this method tight layout. This gives me more room between the plots, or the subplots. And so this isn't crammed. And then furthermore, if we want to save the data, which most people may want to do for publications or websites, we could save it, and I'm going to save it in the plots directory. We use the save fig method, and I'm going to save it at DPI 300. I do that, and I run that, and it's going to probably see a number of plots, but it's going to be very large. But yes, that's as simple as that to save a plot, and I want to run this without tight layout, and you'll see the issues with not using that. And so, let's see. So I'll take questions after I do both. I'll run 2 more cells, but so we've been using Matplotlib's kind of procedural style for creating plots, but it's more useful, especially when you want to create multiple subplots, and especially if you have a workflow that you need to set up and repeat this over and over. So let's get into how to create plots with Matplotlib's object-oriented style. So one of the things you need to do is, you'll see that some of the methods have changed up. We need to actually create these axes. We will create them much like before, and while this first example is fairly similar, it's not really taking advantage of the object-oriented style. We're essentially kind of separating everything apart. We explicitly call the figure, and then we have the axes separated, and it's probably better if you compare them side by side. But one thing I'm going to show you in this next example is that we're able to kind of just get everything as a result of separating everything. I could put this into a function, and while there are a lot of parameters, I think it's 5, we could just we could just call these functions again and then just add these the arguments in to get two different plots. So I'm going to go back up here. As you can see, this version, it looks, as they say, it looks like spaghetti code compared to this version, and it's relatively easy, even if this is even if we wanted to kind of, hopefully I could do this live. Oh, yes, I need to add, I need to change, oh, there we go. Oh. So it's not the prettiest, but but essentially, as you can see, reusability is built in there a lot more. Going from this, if I had to add another plot, it would not be as a nicest thing to do. I think I'm going to take some questions if I have any. One. So would matplotlib object-oriented style be used to embed the figure in a Python GUI application with other I'm actually not sure about that. I think it's just, that may be a question of pumping that code into the specific application, like, but say if that application is like object-oriented based, it may be more beneficial to have that code written that way. I'm not sure if that is the right, if that's what you're asking, but it's definitely, I mean, you always want to, I guess, program for your environment. So let me give you some resources. For NumPy, anybody that's particularly interested in NumPy, and I'm going to come back to object-oriented programming in general after this. NumPy user guide, that's especially helpful if you want an overview of NumPy, and then the masked arrays tutorial. These are both from the NumPy site, and then a lot of these sources are directly from the library's sites, not our library, but the Python packages site. So the intro to pandas, the cookbook, but the one that isn't, I should say, is Daniel Chen. He essentially goes over pandas, and he kind of covers pandas and with data analysis. Specifically, he goes over pandas use cases with tidy data. So he covers that paper, tidy data. I think that was originally written for R, but he covers that in the context of Python and pandas. I think it's like 3 hours. I don't know. It might be. There's a version where it's 3 hours and one that's like 1.5. But if you want to know the nitty gritty of using pandas in a real context, that may be for you. Intro to Matplotlib, user guide, those are pretty helpful. And then user guide covers the structure of Matplotlib. I may just want to go into this to show you the anatomy of the figure, how tricky it could be. If you see this and you're interested in Matplotlib and using it, I recommend you check out that guide. Again, we have a LibGuide. I will promote that. And Commerce Learning Center. If you want to check out programming videos, if you're Fed, you could already do it. If you're a contractor, get your federal manager, bug them until they get you on their access. So I do want to mention this kind of may go back to the first portion of today, that Python, and maybe others could chime in, Python does allow you to do object-oriented programming, but it doesn't strictly require you to do it, say unlike Java. And also when you create classes, it does not, it's not as like strict, and maybe some of those people that like other object-oriented languages that like that strictness may not like that. There's no way that I could have covered that today, or I just thought I would bring that up because I saw a lot of people signed up, if they're here today, a lot of like Java people and I think some C# people. But I thought I would mention that because you can program in a procedural style or an object-oriented style, but I know Python web frameworks are very object-oriented, and I think if you're in that, that's your realm, you may want to look into object-oriented materials. And then I think if anybody has any questions, I will take them, but I could ramble on, but I think I will, my throat's kind of worn out at this point. But if anybody wants to send me emails, I will mention again that we will have a post-webinar survey that will be going out after the second session. I do appreciate feedback, so please send it to me. But yes, and one more thing, I will. I noticed people did mention that they're interested in scripting. Yeah, that's what I primarily do. So please, if you have any questions. So our Python scripts compiled into an executable. Python is an interpreted language. I could just kind of, I don't know if this is going to just me goofing around at this point, but yeah, Python is just, no, you just need to have Python. Like today I asked everybody to have Anaconda installed, but if you're not going to be doing any kind of scientific programming, or if you're just going to be running Python, if you're going to be running scripts, I'm going to go into my personal stuff. Let me, now you get to see the silly names I have for my, you don't need you just need Python installed. So I will run a script that will add something to Heroku, and I just need to run so So yeah, essentially you just need Python installed, no runtime engines. So this script will just, it grabs a CSV file that's public from a Google Sheet, and processes it through a series of libraries and adds it to Heroku for the public. Jupyter Lab, Oh, so how does Jupyter Lab handle simultaneous coders changing the same segment of code? Jupyter Lab, so maybe I should have clarified this a lot earlier. Within Jupyter Lab or Jupyter Notebooks, it's the same ecosystem. You create a single notebook, and it's for the individual. Individual runs it on their own computer. People don't code in it concurrently. It's people could share a notebook after they're done, but it's not intended for multiple people to actually interact at the same time, because that would kind of throw off what's in the specific notebook. So like, say for instance, I run a cell, so an individual cell is, I have here, individual cell, I have a variable, and someone has the same variable, they're gonna mess me up. It's not intended for multiple people at the same time. So, yeah. If we don't have any more questions, I hope everybody enjoyed it. I know there was a couple of skips at a couple of points. This is actually my first time doing a webinar, so I appreciate everybody that showed up today, and I appreciate the questions. And I think we are going to sign off. Have a good day. Oh, we do have one more question. So there's a question of how to interact with Jupyter, the actual notebooks themselves. So, well, let me show you the best way to run a notebook. If you have had trouble, I would say go to the top, and then you don't necessarily have to go to the top, but you want to go to kernel, restart, and then under kernel menu, if you are here, go to restart and run all cells. Essentially, this is going to do a clean run of every cell. And hit restart and run all. And if you are still getting issues, because what this is going to do is just going to run through everything, overwrite. If you're getting any error statements, that you shouldn't get any error statements in the first part one, because these are all, I believe everything is a built-in Python. Everything that's used in the first part is built in Python. But if you run, again, if you go to kernel for the second part, run all cells, if you do get errors, say like write immediately, you shouldn't get that, maybe because of the fact that certain libraries aren't installed. But if that is the case, certain libraries may be installed, and I'd say call me, not call me, email me. I'm not sure. So the question is the value of sharing Jupyter Lab versus a project and a development environment and sharing scripts. Honestly, that's really up to kind of your workflow, the processes you use. Say if you use like GitHub or Git, that's perfectly understandable. I know that's yeah, there that's I I could say I used it for this webinar. I don't often use Jupyter myself. I use it for this webinar as it's good for learning purposes, and that's why a lot of people use it. Um, but I, yeah, I could agree with you. It really depends on your situation and uh, what environment you're in. But I think if there are no other questions, I think we're good to go. We are going to wrap this up, and I think I hope everybody has a good day.